As the decade of the 70s was coming to a close, Bank of America was accelerating its efforts to play a dominant role in the developing electronic banking explosion. The bank was committed to automation in its item processing, its management information system, and its delivery of products and services to its customers. In mid-1981, corporate real estate began to identify alternative locations for a new facility, which could provide greater efficiencies through consolidation of personnel. After a long review process, corporate real estate selected the city of Concord as a most likely candidate, and after favorable discussions with the city, recommended to the bank's managing committee in March 1982 that the bank build a 1 million square foot complex on a 6-block area in Concord adjacent to the BART station. By April 1983, the bank's master plan was accepted by the city, and in June of that year, a development agreement was signed. Land acquisition and relocation of tenants consumed the rest of the year, during which time the bank's architect, Skidmore, Owings & Merrill, in concert with the general contractor, Turner Construction, began the task of designing the project under the direction of corporate real estate. To assemble the 6-block, 15-acre site, bounded by Galindo, Grant, and Oak Streets, and by Concord Boulevard, it was necessary to acquire 29 dwelling units, 37 businesses located on 57 parcels, and 2 parking lots. Next, all the structures, paving, and landscaping had to be removed, along with the top 4 feet of soil, which was structurally unsuitable, to prepare the site for construction. However, one special feature was saved. Concord Heritage Tree number 11, allegedly the oldest black olive tree in California, was moved to a location in the formal garden, or bosque, scheduled for completion 3 years hence. In the interim, the tree would undergo a period of care and maintenance to assure its reestablishment. On December 7, 1983, a groundbreaking ceremony signaled the start of construction. With the site cleared, excavation for the basement of Building D, the data center, began. The basement houses the central plant, which furnishes mechanical and electrical service to all buildings on site. $7,900 cubic yards of concrete, enough to build 1,990 houses, went into the foundations and floor slabs of the structures. office buildings and data center are of steel frame construction, supported by concrete spread footings. In total, 9,800 tons of steel were used. On July 3rd, 1984, a milestone in the construction of Phase 1 was celebrated with the topping out or completion of steel erection for buildings A and D. Each floor of the 6-story data center is the length of a football field and 1 1/3 acres in area. Floors 2 to 6 are built with 18-inch raised flooring to provide space for computer cabling and chilled water pipes to cool computer equipment. By November 1984, buildings A and D are essentially completed, and construction of the 6-story garage is well underway. The ground for Phase 2 has been cleared and is ready for construction. The project involved over 4,000 different crafts, with 470 workers on site at the peak of construction. In spite of its size and complexity, the entire building process consumed only 3 years. Behind the scene, scores of people representing the architect, contractor, and corporate real estate hold meetings, complete and review documents, and schedule field activities. The topping out of the structural steel for buildings B and C, Phase 2, took place on May 22nd, 1985. Major art pieces form the foundation for an outdoor museum where bank employees and the citizens of Concord may enjoy openness and beauty in the city center. With basic construction completed, many finishing touches require the attention of skilled workers. As a major technology center for the bank, the building's design stresses the need for state-of-the-art mechanical and electrical systems, with a building shell permitting maximum flexibility and use. A combination of standard and heat recovery chillers with plate heat exchangers and condenser water pumps in the Building D central plant serve the air conditioning needs of all the structures. An uninterruptible power system of storage batteries and diesel generators is installed to maintain constant voltage at all times. The 3,600 tons of air conditioning capacity is enough to air condition 1,200 houses. A building management system electronically regulates, controls, and monitors all mechanical, electrical, and security building systems. Cross-zone smoke and heat sensors and fire suppressant systems are employed to protect computer and critical communication spaces. Building A, the first building to be constructed and the tallest at 13 stories, was completed in October 1985. Employees began moving in almost immediately and fully occupied the building by January 1986. Building D was fully operational 6 months later. Building B, a 9-story office building, and Building C, 4 stories high, were completed and occupied a year later. To create a clean, modern-looking, high-tech exterior, the buildings are clad in sheet aluminum panels painted dove gray, burgundy, and white. The 550-seat cafeteria, with its earthy colors, greenery, and sunny skylighted interior, provides a serene dining atmosphere. "25 small fountains contribute to the pleasant quality of the outdoor area. A lattice overhang, which wraps around the cafeteria, provides a historic link with Concord's past, emulating the landscape elements of Todos Santos Plaza, planted over a century ago." The Bosque, with its 17 small fountains and flowering fruit trees, forms a link between the campus and BART. A less structured urban forest of randomly planted deciduous trees grow around the office buildings. Romantic willow trees grace the lawns, which carpet the site, helping to create a pleasant working environment with majestic views of Mount Diablo and the surrounding hills. Heritage tree number 11 forms the centerpiece of the Bosque. 3 years after it was moved to its present location, it is in excellent health, assuring its continued growth for several hundred more years. The 4-story skylighted atrium, with its sculptured stylized palm trees, forms a dramatic lobby and light well for Building C. Prefabricated panels with fabric-covered acoustic cores are assembled to form workstations of varying dimensions. The stations include integrally designed work surfaces, storage units, task lighting, and wiring to accommodate both data and voice equipment. The stations provide efficient yet comfortable work areas with a surprisingly high degree of privacy. The Technical Library, located on the ground floor of Building C, contains an extensive collection of periodicals and reference material. For the convenience and exclusive use of employees, a branch bank is located off the main lobby of the operations building. In bright and cheerful surroundings, employees are served at sit-down teller stations. garage with 6 parking levels accommodates 2,500 vehicles. Open to the public, it produces income for the bank and provides parking facilities for BART commuters. Bank America's Technology Center, the home of BASE, the bank's systems engineering division, plays a key role in growth and development strategies and represents years of planning and the efforts of many. Those who participated in its design and construction can take great pride in what they have accomplished. In turn, the relocation of BASE to Concord means a major step toward consolidation and greater efficiency. Bank America Technology Center is a job well done, from start to finish.
This is the Bank of America Concord Technology Center, located in Concord, California. It is part of B of A's network of data centers located throughout the world. These centers control the entire Bank of America financial network. Among these valuable facilities, the Concord Technology Center provides the bank with critical and unique services. These include developing new and innovative banking products, and acting as the designated disaster recovery facility. Completed in 1986 at a cost of just over $200 million, this center is operated by BASE, Bank of America Systems Engineering. The backbone of this facility is the mainframe CPUs and DASD storage devices, where 1.3 trillion characters of data are stored, and 400 million instructions can be processed in 1 second. These computers provide services to over 12,000 users and can support in excess of 2,000 terminal sessions at the same time. These mainframes represent the very latest in computer hardware, giving Bank of America computer experts an edge in programming for tomorrow's technology. The mainframes are controlled by the bank's console operations, where highly trained specialists control and troubleshoot the system every hour of the day, 365 days a year. This monitoring system has allowed the bank's 2,500 programmers and an international management information systems network to operate with little or no interruption since BASE began operating this technology center in 1986. This technology center has developed a highly efficient tape operation. Over 130 tape drives operate around the clock. Each of these drives is capable of storing and retrieving 3 million characters of information per second. This tape management facility operates with a number of innovative products. These include the John Deere Tape View system, and Storage Technologies' robotic tape library, which is capable of finding and loading a tape in just a few seconds. An integral part of the Concord Technology Center is its printing operation. These IBM printers process over 30 tons of paper a month, providing output for all of the important programming done here at the center. Each of the IBM laser printers can print 200 pages in 1 minute. BASE recycles all of its printer paper. Joe Irvin, Senior Vice President on the Concord Technology Center.
I'm talking to you today from the Technology Center in Concord, California. This room that we're in here today is one of the many labs that our engineering and design personnel map business requirements to technology opportunities. We have several thousand people that work here in this facility that are designers, who are programmers, who are architects, who are business experts in the area of financial services that meet together in teams to formulate and influence financial services industry in the future.
Supporting new products are Bank of America's test centers located here at Concord. These facilitate the product development of the 2,500 programmers at the center. All new products, including point-of-sale technologies, are tested and certified for production after heavy use in these highly specialized centers. Network operations. B of A and AT&T network specialists on site 24 hours a day, providing end-to-end management control of all of the bank's critical network links. Peter Hill, Senior Vice President of Bank of America.
Well, what we have built and are continuing to build is a multimedia electronic highway for the future. This network control center processes over 3 million electronic transactions a day. We use tools, in many cases, supplied by vendors, suppliers like AT&T and IBM. But we've also implemented techniques and tools of our own that are really not available any other place in the industry.
These innovative products include the Graphic Network Monitoring System, which scans the status of the 14,000 IBM PS2s located in B of A's branch offices, and reports every 10 seconds on the status of each connection. If a problem arises on the network, the GraphNet system allows support staff to zoom in on the failing component and perform corrective action. BASE has created a centralized software distribution network which feeds new and updated software to the personal computers located in the bank's branch offices, guaranteeing uniform loading of software developed here at Concord.
From Bank of America. How are you this afternoon?
An important part of the Concord Technology Center is the Communications Service Center, or Help Desk. Here, computer experts provide centralized computer assistance to Bank of America employees all over the western United States, ensuring operation of individual computers located throughout the network. Besides being used for new product development, the Concord Technology Center also serves as the corporate backup site for production data processing activities. All critical data necessary to recover Bank of America's systems are stored here at the center. In addition, copies of selected transactions are electronically journaled in Concord to further reduce the bank's exposure. This backup system could, in case of a disaster, replace any one of the regional data centers. For instance, if an earthquake should damage the Los Angeles data center, Concord could assume all of LA's data processing from over 400 miles away. This includes providing online services to all Bank of America locations normally serviced by the Los Angeles data center. With sensitive and classified work constantly being developed and stored at the center, the bank has invested in a state-of-the-art security system which protects all of Bank of America's customer information. This system includes internal controls such as the Resource Access Control Facility, or RACF, and VM Secure. In addition, remote video cameras are located throughout the center. These cameras and internal controls are monitored 24 hours a day. With all of this high technology, Base Operations has built an infrastructure here at the center designed to prevent this huge system from ever going down. It begins on the ground floor, where 7 megawatts of electrical power are transformed and distributed throughout the facility. All critical power entering the building is looped through a UPS backup battery system, which prevents any power glitch from interfering with this computer system. In the case of a utility power outage, 7 diesel generators capable of producing 10 megawatts of electricity can power the 1 million square feet of the Technology Center for 7 days without any interruption. In addition to the electrical system, the distribution of chilled water is crucial for operating this facility. Chillers and pumps provide over 4,000 tons of cooling capacity to the computers and air conditioning system. On a peak day, over 39 million BTUs of heat can be dissipated. All of this important infrastructure was designed to withstand an earthquake of an 8